Okay. Good morning, students. So we'll continue with the introductory part of applications of integrals, right? So we have discussed earlier. The area bounded by the curves is nothing but area of the integration. Okay. So we have discussed how to take the limits. In the case of the curve lying on x-axis, it is y dx. The curve is lying on y-axis, it is x dy. So function should be converted to x in case of y dx. In case of x dy, function should be converted into y. So depending upon y-axis, the y function will be there. X-axis, x function will be there. But preferential mode is x-axis only. Y-axis is compulsory in some cases where you cannot convert the curve into x-axis mode. Okay. Some cases the curve is homogeneous. You can take either by x-axis direction or y-axis direction, right? If the curve is divided into 4 equal parts, okay, like this. Suppose this is a homogeneous curve, right? Homogeneous curve, circle, like this. Or suppose ellipse, likewise. Okay, this is a homogeneous. All the 4 parts are equal. So you find one part in one quadrant and you multiply with 4. Or above x-axis, you have to read it. Above x-axis, below x-axis. First quadrant above x-axis, second quadrant above x-axis. Like that, it will be specifically. So in such cases, what to do? Specifically, you have to identify the region and take the limits. In case of y dx, take the x limits. In case of x dy, take the y limits. So for x-axis, take y dx and consider x limits. For y-axis, take x dy and consider y limits. Okay, so this is x-axis, so take y dx like this. So x limits, you have to take 0, 0, a 0. Suppose this is 0, 0, this is 0, a. So in cases you have to take y limits, this is x dy. So likewise you have to go. And in case of symmetric curve, for symmetric curves, always the component parts are equal in area. So this area, this area, this area, this area, all the parts are equal in area. So likewise, you have to take the respective area and then you have to adopt the area of the region bounded by specific curve which has to be mentioned. So the area also should be the highlighted or bounded area can be identified by the question with respect to quadrant and bounded lines. So you take the question with respect to quadrant and bounded lines, x-axis, y-axis, above x-axis, below y-axis, positive side, first quadrant, like that. You have to take the area with respect to the question. And once you are clear with the question, you have to draw the figure and you have to locate depending upon the curve nature. The function is the curve is depending upon x-axis. You have to take y dx and consider x limits only. And in the case of y-axis, you have to take x y limits and you have to take the x dy because these are parameter. So x means what will come? F of y. F of y dy. X is equal to, this is area or integral f of x, y means dx. This is y dx, this is x dy. In case of x dy, y limits. Right? Only y values. In case of y dx, take x limits. Abscissa. This is abscissa, this is ordinate. Okay, the values only you have to take like that. And specifically you have to bound the region with respect to the quadrant as well as axis, positive, below. Then we'll get to know how the problems are specified according to the question. Are you clear? So the question is a clear indicator. Reading the question thoroughly is the key to identify the bounded region. If you want to take the bounded region, you have to identify the bounded region. You have to read the question thoroughly and carefully. That is very, very important. Otherwise, what happens? You will not be able to know what is actually the region bounded, and then you are unable to identify the direction. So that what is there, you will not be able to know. Are you clear? So reading the question thoroughly is the key to identify the bounded region. The highlighted or bounded area can be identified by the question with respect to quadrants and bounded lines. Symmetric curves always, okay, the component parts are equal in area. For x-axis, example, circle, ellipse, etc. They are all symmetric curves. Hyperbola is not a symmetric curve, as well as parabola is also not a symmetric curve. But parabola up and down is symmetric. But always you cannot take the left and right parabola like that. So for x-axis, take y dx and consider x limits. For y-axis, the curve. Okay. The nature of the curve depends on x-axis, take y dx and consider x limits. Y-axis, take x dy and consider y limits. In the case of the area is equal to integral f of y dy. That is f of y is x, f of x is y. Okay, like x. This is take y limits, this is take x limits. This is the total essence of how to proceed the problem. Already we have seen yesterday one question. Still we will see the specific cases. Now we have seen only with axis one curve. Then we will see two curves and line, two curves and axis, one curve, one axis, like that we will proceed. Okay, there are multiple and various combinations of bounded region, intersection of the curves also. Then sometimes the points also will not be given. We have to extract the points or the limits. That all we'll discuss one by one, slowly, one after another. Okay, right? So I think you are clear with this part. Just make a note. Then we'll proceed to one question application. Please make a note of this part. Okay, now we'll see. Find the area bounded by the curve. Y square is equal to x equal to 4 minus y square and the y axis. See, find the area bounded by the curve x is equal to 4 minus y square and the y axis solution. The given curve is x is equal to 4 minus y square, that is equal to y square is equal to 4 minus x, that is equal to minus of x minus 4. So of the form y square is equal to 4ax. Minus 4x. So minus 4x means it will be what comes here? So it was given like this, minus y square is equal to minus 4ax. Okay, so it is symmetric to x-axis, and since the power of y is even, because y square is equal to means symmetric to x-axis, x square is equal to means symmetric to y-axis, already parabola, you know. So we can draw the figure first. Okay, so how will we draw the figure? So what will come here? Vertex is 4 comma 0. So you will get here because vertex is 4 comma 0. Next, we take here this part. So dx and this is y. Okay, so area of the curve is equal to boundary by the curve both on the above and the y-axis. Y-axis means both will come because okay. So since the curve, the area is required with respect to curve and y-axis, A is equal to this one, this area A1 plus A2. Since A1 and A2 is congruent to A2, y is equal to 2A, A1. Okay, this is 0, 0, right? So this area is equal to this area, y-axis means both will come. So A1 is congruent to A2, y is equal to 2A1 will come. So okay, then what comes here? Therefore, A is equal to 0 to 4. Integral 0 to 4 y dx. What is y? Okay, 0 to 4 root of 4 minus x dx. That is equal to 4 minus x whole power 3 by 2 by 3 by 2 into minus 1, 0 to 4 by 0 2 by 3 into minus 2 by 3 into 4 minus x whole power 3 by 2, 0 to 4. That is equal to so 0 minus 4 whole power 3 by 2 minus 2 by 3 into minus 8 minus of 2 square 8, 16 by 3. So 2 into will come here. Because 2 times area, na? So 4 by 3 minus 4 by 3 into minus 8, 32 by 3 square units. This is what you get. Okay, clear? Understood now? Like this you get. So first you have to draw the figure, identify the region, then take the respective limits and then form the function and then you go with. This is the area like that you will get. I think you are clear, Raj? Okay, right now clear? So we'll go to next question. Yes? Thinking is the same. Next question. So we'll see some sketches of some standard curves. Sketches of some standard curves. So equation of curve, sketch. I'll go for a tabulation. First, straight line, x is equal to a greater than 0. X is equal to minus a less than 0. A greater than 0, this also. Left side, okay. Sketch or diagram. A, first case. So draw this figure. X is equal to minus a. X is equal to a. Next question, B. Straight line, y is equal to b. Bigger than 0, y is equal to minus b, bigger than 0. This is y dash, and this is x dash. 0 b, 0 minus b, y is equal to minus b. Like this, you will get the sketch. Now down. This is a standard sketches. You can use it. Okay, next question. Next figure will go. Write and y equal x and y equal minus x. See, y is equal to x and y is equal to minus x. So we'll go for this part. Because figure is very important for finding the area. So y equal x will be diagonal this way, and y equal minus x will be this way. Put D. Straight line x by a. Again x by a plus y by b is equal to 1. A not equal to b. Here x plus y is equal to a. This case next x by a plus y by a is equal to 1 if a is equal to b, or x by b plus y by b is equal to 1, x plus y is equal to a, or x plus y is equal to b. In that case, what happens? Here a0, 0a, here 0, 0, here x plus y is equal to a. Otherwise, you can use b0, 0b, 0, 0. This is b, this is b. X plus y is equal to b. This is the figures. Here a is equal to b means this case will come. First case, second case, these two figures will come. So this is y-axis and this is x-axis. Y dash, x dash. Here also y dash. This is y, and here x dash. This is x. Y dash, x dash. Is it clear? Next question. If you remember these curves now, or else have an idea, you'll be able to clearly knowing that to plot the region or identify the area bounded by the curves. That's what you have to go. Starting days are over. Now we'll go for next days. Modulus function. So it will be like this. It will be only in the positive axis. Lies only in Q1 and Q2, positive y-axis. So this is y dash, x dash. This is 0, 0. Y is equal to mod x. So this is modulus function, already you know it, right? Next, circle x square plus y square equal to a square. So automatically radius is a, okay? So center is the origin. And is symmetric to 4 axes, both axes. So origin 0, 0, here a 0, here x dash, x, y, y dash. Symmetric to both axes, both axes. Suppose you want to find the area of this curve, find one quadrant and into 4, okay? Therefore, area of circle is equal to 4 into area of Q1. This is Q1. There is nothing but dx and this is y dx. That is equal to 4 integral 0 to a y dx. That is equal to 4 integral 0 to a root of a square minus x square dx. Y means you'll get root of a square minus x square, likewise. Because one quadrant is symmetric to all the other 4. So you can get like this area. Next question. Once you are clear with the diagram or sketch, now it is easy to identify for you the bounded region and you can able to proceed. Once bounded region bounded, automatically locate the respective points, limits, and then you can proceed with that. Parabola y square equal to 4x and y square is equal to minus 4x. So automatically you will get a curve like this. Y square equal to 4x means this will be, and y square is equal to minus 4x means this will be. This is minus a0, this is a0 x. So minus a to a, here minus a minus 2a. Minus a to a on this also. And minus 2a this here. Here you can go like that. A to a minus 2a. This is origin. Vertex 0, 0. Focus S is equal to a0 minus a0. Okay, length of lattice rectum over here. Okay, like that you have to do it. Length of lattice rectum a minus a minus 2a likewise. Okay, this is what you have to do. Next, parabola x square is equal to 4a. Same case, 4a and b. And x square is equal to minus 4a. So what you get here? Up and down parabola. Here 2a, here minus 2a, and this is minus 2a minus a. 2a minus a. This is vertex O 0 0, focus S is equal to 0a or 0 minus a. Length of lattice rectum is equal to 4a. Okay, so parabola you are clear, left and right parabola, up and down parabola. Okay. Next, ellipse. Symmetric to x-axis. X square by a square plus y square by b square is equal to 1, a greater than b. Versus plus or minus a comma 0. Center 0 0. No, Next, and y-axis. We'll go for y-axis also. X square, y square by a square. X square by a square plus y square by b square is equal to 1 when a less than b. Okay, note it down. I think you're clear. Ellipse also we have taken both cases. Then hyperbola is not there. Parabola ellipse is given because hyperbola is not given because this is open curve. Note. Hyperbola is a open curve. So that's why. So it won't be discussed. It won't be part. That's a ellipse and a circle we got, ellipse we got, parabola we got. Hyperbola will not be there because hyperbola is open curve, both sides. So it won't be part. So we will not discuss that part mostly. In the case of that, we'll take two part of parabola as hyperbola. Okay, likewise. Next, sine function. Y is equal to sine x. So automatically you know sine x means sine 0, 0, 90, like that you get, right? So from 0 it will start. Here pi, here 2 pi. Area of one loop is equal to all loops. Area of each loop is equal or same. Next, cosine curve will go. Cosine function. Cosine function. Y is equal to cos x. So here what comes here? 0 is gone. So what comes here? It will come like this. So this is 0, 0. This is 0, 1. This is pi by 2, 3 pi by 2, likewise. Pi by 2, likewise. A, B, this is pi, this is 2 pi, etc. Area of each loop is same. So you'll get alternative here 0 pi 2 pi here 0 pi by 2 3 pi by 2 5 by 2 in between pi will come here pi by 2 will come likewise. Okay, so here 3 pi by 2 likewise. So one loop is equal to area. So you find this area is equal to 2 parts means up to here down means 2 into. If you want to take half part means you take half. Likewise you will take the respective boundaries. Very clear? So this is the standard functions and the sketches. So far we have discussed. So first you draw the sketch. That is very important to find the area. Note. To find the area bounded, draw the sketch, locate the boundaries, and then identify the region. Then integrate with respect to x dy or y dx. X or y. So this is the draw the sketch, locate the limits x and y, identify the region, integrate with respect to dy or y dx. In this case, you'll get the area like this. This is the standard format you have to go. Okay. So now already we have seen sketch of curve of area with respect to axis and one curve. Now two axes, two curves, axis, curve and line, like that we will discuss multiple cases. Okay.